Add and subtract. Allie needs to do strength training after a stroke. During a session, she would spend a third on her legs, 4/15 on her lower back, and the remaining of the time would vary on the exercises. How much total of each session was spent on just her legs and lower back? So before we answer this question, let's go over a few things. We will call these the LCM tricks. So it's a series of questions that you can ask yourself in order to solve for adding or solving fractions. So the first question will be, is one a multiple of the other? And if the answer is yes, then just multiply. So the example would be if it's 1/4 plus 3/16. So we can see that 4 is a multiple of 16. So therefore we can go 1/4 and we would just multiply it by 4 times 4. So that gets us to 16. Plus 3/16 will equal our answer. That's how we would solve for this question if this was presented to us. The next question is, if this was no originally, then you would have to ask, do they have common factors? And if the answer is no, then just multiply. This would be if you have 1/7 plus 1/11 equals what number? So we know that 7 and 11 both are prime numbers, and they have no common factors between the two. So what you would have to do would be, you would have 1/7, and then you would multiply it by each other numbers. So we would have this, and this is how we would set up our problem if the answer was no, for no common factors. But if the answer is yes, then we use prime factorization. And what we do is what we do is use each unique factor, and we take the highest exponent for each factor. So let's now go back to our problem. So for this problem, we are looking at the total amount of time that is spent on just her legs and lower back. So we will be adding 1/3 plus 4/15. Now, the first question we ask ourselves is one a multiple of the other? So we look at the lower number, 3, and we look to see if 3 goes into 15. And in fact, it does. So 3 times 5 would equal 15 for us. So 1 is a multiple of the other. So what we'd have to do is just multiply the 3 to get to 15. And how we do that would be, to multiply it by 5 on top and the bottom. We do this because whatever you do to the bottom, you must do to the top, as then it's just multiplying the whole number by 1. So we would have this plus 4/15, and we'll just leave as is because we want to keep this at 15, so we get the common denominator. So the next step would be to multiply out. So we would go 1 times 5, which is 5, and then 3 times 5 is 15. Then we will add 4/15. And this will get us to our final solution. So we add 5 plus the 4 is equal to 9/15. Now the next step would be to see if we can reduce, which we can. Both are able to be divided by 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. So this is our final solution. So let's look at another example. Example 2. Allie does exercises at home and is required to do a certain amount each day. By midday, Allie had 11/20 left to do of her strength exercises. By late afternoon, she completed 2/15 of her total time. How much does she have left to do? So for this problem, we have 11/20, and then she completed another 2/15 of the total time. So that means we're going to subtract to get the remainder amount of time that she has left to do. So the first question we always ask is one a multiple of the other? We see we have 20 and we have 15. So if we multiply 15 times 2, that number is 30. So one is not the multiple of the other. So the next question would be, do we have common factors? And the answer would be yes, because 20 and 15 are both have a multiple of 5. So we would like to use prime factorization in order to solve this problem. So how we do that would be to take 20 and let's do our prime factorization. So we have 20. Let's first divide by 2. And that gets us 2 and 10. Now 10 can be further divided by 2 and 5. So these are the prime factors of 20. Now 15 can be broken down into 3 and 5. And that's it. So like we said, we have a common factor of 5. And what we do with prime factorization is we take each unique factor. So we would take 2 times 3 times 5. Those are our unique factors for all these numbers. And then we're going to take the highest exponent for each factor. Now for 2, we have 2 of them. So we would put a 2 here. 3, we just have 1, so we'll just leave as is. And each one has 5, so we'll leave that as is. So our new common denominator would be from this. So 2 times 2 is 4, times 3 is 12, times 5 is 60. So this is our common denominator. So the next step will be to multiply each of the numbers by the missing factors. So let's go ahead and do that. So we have 11/20 and 2/15. Now, when we look at 20, we see that we have the 2 2s and the 1 5. So the only missing factor in the 20 is the 3. So we would go ahead and then just multiply this number by 3. And this is confirmed that we are just missing that because 20 times 3 is equal to 60, which is the number we need for our common denominator. Next, we're going to look at 15 and see what we're missing. So we have a 3 and a 5. So the only numbers we're missing in the 15 is these 2's, as we have the 3 and the 5 otherwise. So we would multiply this number by 4 on both the top and the bottom. And 15 times 4 is equal to 60. So we know we did that right. So now let's go ahead and multiply these numbers out. So we have 11 times 3, which is 33 over 60, minus 2 times 4 is 8 over 60. So this gets us to 25 over 60. except actually this is not our final answer as it's not reduced. So we can go ahead and reduce this number by 5, both on the top and bottom, because both numbers end in a 5 and a 0, so we know it's a multiple of 5. So 25 divided by 5 is 5, and then 60 divided by 5 is 12. So this is actually our final answer for this problem. Now let's go look at another example. Solve 3/7 plus 8 over 21. So our first question we ask ourselves is one a multiple of the other? And for this problem, we would say yes, because 7 is a multiple of 21. So this makes this an easier problem, as we know that 7, if we multiply that number by 3, we'd get to 21. So 21 will be our common denominator that we're going for. So we would multiply the top and the bottom of 3/7 by 3. And then we would add plus 8 over 21. So let's go ahead and do this multiplication out. So 3 times 3 is 9, which is over 21, plus 8 over 21. And this gives us 9. Now plus 8 is 17 over 21. And this is our final solution for this problem. Let's look at one last example. Solve 5/8 plus 4 over 11. So the first question we always ask is one a multiple of the other? And we see we have an 8 and an 11. And so 1 is not a multiple of the other, as we can't do anything to go from 8 to 11. So that would be a no. So the next question we would ask is do they have common factors? Now we know 8 can be broken down into 2 and 4, and then 4 can be broken down into 2 and 2. So it's just a factor of 2's. Now 11 is a prime number, so it can't actually be broken down. So they do not share any common factors. And if this is the case, then we're just going to multiply. So we would have 5/8, and we're going to multiply it by 11 over 11. And then we have plus 4 over 11, and we're going to just multiply this number by 8 over 8. I'm going to go ahead and just erase this. So the reason we do this is we're just going to multiply because our answer was no. So now we can go ahead and begin to multiply. So 5 times 11 is 55 over 88, plus 4 times 8 is 32 over 11 times 8 is 88. So then we would go ahead and add these two numbers together, as we now have a common denominator of 88. So 55 plus 32 is equal to 7, because 5 plus 2 is 7, and 5 plus 3 is 8. So we get 87 over 88. And this would be our final solution. So just go ahead and remember these little tricks of asking yourself a couple questions in order to solve these problems